Hi there! In this video we are going to learn how to build node networks from scratch. This is quite important because building networks on your own will give you more power and flexibility in your creative process. We are going to model a basic airplane engine creating nodes directly in the network editor. Let's use an image as a reference for our modeling process. In the viewport options, set the view to front. Now, to load a reference image in the viewport, press D to show the display options. Go to the background tab and use the file browser button to load an image. And check the autoplace image option. Close the display options. Now, go to the network editor, press Tab to display the Tools menu and start typing Geometry. As soon as the tool is highlighted in orange, press Enter twice. OK, we have created an empty object. Rename it as Engine. Now, double-click to dive inside. As you can see, we have nothing inside. Looking at the image, in this model, the casing, the spinner, and the turbine can be generated by drawing curves and then revolving them around the x-axis. To build the fan blade, we can create one blade by drawing and extruding a curve and then copying around the x-axis. Let's start. In the network editor, press Tab, start typing curve, and as soon as the tool is highlighted in orange, press Enter twice. A curve node is placed in the network editor. Go to the viewport and press Enter to display the crosshair cursor to draw the points. Start placing the points to define the casing. Before finishing, in the Parameters tab, check the option Close and change the primitive type to NURBS. Go to the viewport and press Enter to finish, and press W to change to wireframe mode. Now, drag the points to better conform the curve to the reference image. But in the upper part, let's make it more round. OK, rename the curve node as Casing. Let's do the spinner now. We need another curve node. Press Tab, start typing curve, and as soon as the tool is highlighted in orange, press Enter twice. Start placing the points and press Enter to finish. In the Parameter tab, change the primitive type to NURBS. Now, to make sure the first and last points are exactly in the x-axis, their y-coordinates must be set to 0. In the coordinates field, press Alt-E. In the first point, change the y value, the second one, to 0. In the last point, also change the y value to 0. Click on Apply and Accept. In the viewport, drag the other points to adjust their positions. OK, rename the curve node as Spinner. Now, repeat the same process for the turbine. Create a curve node. Place the points. Change the primitive type to NURBS. Set 0 to the y value for the last point. Drag the other points to adjust their positions. Rename the node as Turbine. OK, save the scene and give it a name. Let's draw a final curve for our blade. Once again, the same process. Create a curve node. Place the points. In this case, check the Close option. Change the primitive type to NURBS. Press Enter to finish. Drag the points to adjust their positions. rename the node as Blade. In the network editor, you can only have one node with the display flag. You can see the casing, or the spinner, or the turbine, or the blade. To combine geometry, you have the Merge node. Press Tab and start typing Merge, and as soon as the tool is selected, press Enter twice. You can connect different geometries to the Merge node, one by one. To delete connections, hold the Y key and drag across the connections. You can also select all the nodes to be connected and drag one output port to the Merge input port. For now, let's delete the Merge node. To have more room to work in the network editor, in the Viewport Layout menu, select Split Pane Left-Right. Now, right-click on the scene view and select Parameters. Finally, minimize the top right pane. In the Viewport Layout options, select Two Views Stacked and set the bottom viewport to Perspective. OK, let's revolve the casing curve, but as this is a nerve curve, let's first convert it to a polygonal curve. Click on the output port on the casing curve and drag. Now press Tab, start typing Convert, and as soon as the tool is selected, press Enter. A Convert node is placed. Change the display flag to the Convert node. With the default parameters, the nerve curve is converted to a polygonal one. Now, click on the output port of the Convert node and drag. Press Tab and start typing Revolve. As soon as the tool is selected, press Enter. A Revolve node is placed. At the moment, in the axis direction field, a value of 1 is set in the y-axis component, but we need to revolve the curve around the x-axis. So, type 0 in the y-axis and 1 in the x-axis. Now we have the required shape. To have a better resolution, increase the divisions from 12 to 96. That's better. The spinner and turbine curves require the same treatment. You could select the Convert and Revolve nodes, then Ctrl-C to copy and Ctrl-V to paste them. But there is a faster way to do this. Select the Convert and Revolve nodes. Hold Alt, click on any of the selected nodes and drag them. Click on an empty area. Now drag once more to have another copy. Now you can release the Alt key. Connect the output of the spinner curve to the input of the Convert 2 node and the output of the turbine node to the input of the Convert 3 node. OK, at the moment the turbine shape is visible. Change the display flag to the Revolve 2 node to see the spinner shape. It's OK. Now, the blade does not need to be revolved, only extruded. Just copy the Convert node. Hold Alt, drag the Convert 3 node, click below the blade node and release the Alt key. Connect the output port of the blade node to the input of the Convert 4 node. In the viewport, press W to toggle from wireframe to shaded mode. Good, we have the blade shape, the turbine, the spinner, and the casing. Let's merge the revolved geometries. Press Tab and start typing Merge, and as soon as the tool is selected, press Enter twice. Now select the 3 revolved nodes. Click on any output port and drag to the Merge input port. The connection is done. Change the display flag to the Merge 1 node. OK, our 3 geometries are displayed at the same time. In the shading options, select Smooth Wire Shaded. Let's work on the blade. Change the display flag to the Convert 4 node. To have the spinner as a reference, click on the template flag of the Revolve 2 node. To extrude the blade, click on the output port of the Convert 4 node, drag, press Tab, start typing Poly-Extrude, and as soon as the tool is selected, press Enter. Change the display flag to the Poly-Extrude node. In the viewport, press Enter to show the tool handles. Drag the distant handle to add depth to the shape. Now let's twist the blade. Click on the output port of the Polyextrude 1 node and drag. Press Tab, start typing twist, and as soon as the tool is selected, press Enter. Change the display flag to the twist node. In the viewport, as the help text shows, press B to cycle the capture axis. Now use the ring handle to twist the blade. Let's round it to -75 degrees. To copy the blade around the x-axis, we are going to use the Copy and Transform node. This node is very useful to copy geometry, changing position, rotation or scale. In this case, we need to change rotation. As usual, click on the output port of the twist node, drag, press Tab, start typing Copy and Transform, and as soon as the tool is selected, press Enter. Change the display flag to the Copy 1 node. In the viewport, we can see that we need to copy and rotate around the x-axis. In the Parameters tab, in the Rotate X field, type 10 degrees. Now, how many copies? A full circle is 360 degrees, so we need 36 copies. In the Total Number field, increase the value to 36. Okay, we have the fan blades. Let's connect the Copy 1 node to the Merge 1 node and change the display flag to the Merge 1 node. Good, the model is almost finished. Although the model was done following the image reference, the spinner and the blade seems a little hidden in the casing. Let's move these elements slightly outside. To move the spinner and the blades as one element, we can merge them and then move them. Hold Y and drag over the connections to disconnect them. Now reorganize the nodes to put the spinner stream next to the blade stream. Press Tab, start typing Merge, and as soon as the tool is selected, press Enter twice. Connect the spinner and the blade streams to the Merge 2 node. Reconnect the turbine stream to the Merge 1 node and connect the Merge 2 node to the Merge 1 node. Now press Tab, start typing Transform, and as soon as the tool is selected, press Enter twice. Now to insert the node, drag the Transform 1 node over the connection between the Merge nodes. In the viewport, we can use the handles to move the geometry in the X direction. But what geometry are we moving? Of course, we are moving the combination of the spinner stream and the blades stream. In the viewport, press W to toggle to shaded mode. Click on the bypass flag on the casing curve node. Now we can look inside. As you can see, we have a gap, so we also need to extend the initial part of the turbine. It can be done by modifying the nerve curve points or by editing the converted points. Let's try the first approach. Change the template flag to the Revolve 2 node and the display flag to the Turbine Curve node. With the Turbine Curve node selected in the viewport, press Enter to show the curve points. Now you can drag the points to adjust their positions. If there are many points, it can be tedious. By the way, we need to change the template flag to the Transform 1 node. Now, to edit the converted points, select the Convert 3 node. Click on the Select tool, select the option Points, and drag a selection around the required points. Press T to move them. An Edit node has been added and you have the transformation handles to move the selected points. Use the X-axis handle to move the points. Change the display flag to the Merge 1 node. OK, we have filled the gap, and if needed, you can use the Soft Radius option in the Edit node to have a soft transition in the transformation. With 0.5, it looks more uniform. Looking more closely, the fans are hollow. When the extrusion was done, I forgot to activate the Output Back option. But no problem, you can change any parameter at any moment. Select the Polyextrude 1 node and activate the Output Back option. Let's disable the bypass flag on the casing curve node. An important detail: the polygons in the viewport are represented in light gray, but at the moment our polygons are displayed in dark gray. Because of the way we revolve or extrude our geometry, we end up with reversed polygons. It will cause issues during the render process. To fix this issue, there is a reverse node to help us. You know the routine. Press Tab, start typing reverse, and as soon as the tool is selected, press Enter twice. Drag the node over the first stream. Now hold Alt and drag to the other streams to have more copies. You can see the color is okay now. When building networks in Houdini or any other node-based program, it's important to keep the network organized. Not to have a nice graphic to show, but to have an easy to read and easy to edit graphic. As needed, rename the main nodes with descriptive names. You can also use color to add more clarity to your graphic, and you can use the layout menu to arrange your nodes. Let's try it. Select the first stream. Go to the layout menu and select Align Nodes vertically. Repeat the process with the other nodes. Activate the Show Color palette. Select nodes and apply color according to their type. Another good practice is to add at the end a dummy or null node. Click and drag on the output port on the Merge One node. Press Tab, start typing null, and as soon as the tool is selected, press Enter. Rename the node as Out in capitals. Let's also color it in black. A final issue in the network. In the Merge To node, you can see a yellow warning sign. If we click on the information icon on the node, a message says that a mismatch of attributes on the inputs was detected. An attribute named UV is causing a problem. If we check on the left stream, we have two attributes, a point attribute P and a vertex attribute named UV. On the right stream, on the other hand, we have only one attribute, P. To fix this warning in the merge node, let's add a UV attribute to the right stream. Let's make some room. Now press Tab, start typing UV texture, and as soon as the tool is selected, press Enter and drag the node over the connection between the Polyextrude 1 and Twist nodes. The warning is gone, and you can check both streams have the same attributes. To add detail, let's make some cuts in the casing using grid planes. Press Tab, start typing grid. As soon as the tool is selected, press Enter twice. In the Parameter tab, in the Orientation menu, select YZ plane. Set the rows and columns to 2 and the size to 2.5. Click on the output port of the Grid 1 node. Drag, press Tab and start typing Transform. Once the tool is selected, press Enter. Now, to duplicate the node, hold Alt and then drag the Transform node twice. Select the Transform To node, go to the viewport and press W to toggle to wireframe mode. Use the X-axis handle to relocate the grid. Repeat the process for the Transform 3 and Transform 4 nodes. Now add a Merge node. Connect the Transform nodes to the Merge 3 node. In the viewport, press W again to toggle to shaded mode. In the network editor, rename the Grid 1 node as Cutting Plane. Now press Tab, start typing Boolean, and once the tool is selected, press Enter twice. Connect the Reverse 1 node to the input A on the Boolean node, and connect the Merge 3 node to the input B. In the parameter editor, as the input B is a set of grids. In the Set V section, change the Treat As field to Surface, and also change the operation to Shatter. The casing has been cut by the grid planes. In the Output Edge group, check the AB Seams field. This group corresponds to the edges highlighted in green in the viewport. We are going to bevel these edges. At the moment, I'm having stability issues with the new Polybevel tool on my computer, so for now I'm going to use the old Polybevel tool. Select the Transform To node and make a final adjustment to the position using the Z-axis handle. OK. Change the display flag to the Boolean 1 node. If I press Tab and type Polybevel, I just find a new version. So I go to the Polygon Shell tool and click on the Polybevel All tool. Now I change the selection type to Edges. Select some edges and press Enter. A Polybevel All node has been added. In the Group field, double-click to select all the edges and press Delete. Now select the AB Stream group. Change the shape to round, the divisions to 4, and increase the offset to 0.015. Change the shading options to Smooth Shaded. In the Network Editor, connect the Merge 1 node to the Polybevel 1 node. Change the display flag to the Out node. Let's reduce the bevel by decreasing the offset to 0.010. Let's just keep the exterior cutting planes. Hold Y and drag below the connections of the Transform To node. Change again the shading options to Smooth Y Shaded. And add color to the cutting plane node. Let's add another cut to the casing, this time with a box. Add a box node. Put the display flag on the Box 1 node and the template flag on the Polybevel 1 node. Click on the Selection tool and select the Primitive option. Select the front and back faces of the box. Press Delete. A Blast node is added and the selected faces are deleted. Now select the Box 1 node and use the transformation handles to adjust size and position. To see better how the box is with the casing, add a temporary Merge node and connect the Blast 1 node and the Polybevel 1 node. Change the display flag to this new Merge node. Select the Box 1 node and continue adjusting position and size. OK. Now hold Y and drag below the Blast 1 node to cut the connection. Change the display flag to the Blast 1 node and select it. Let's add some bevel to the box. Use the Select tool with the Edges option and select the 4 edges. In the Polygon tab, click on the Polybevel All tool. In the Parameter tab, change the shape to round, the offset to 0.035 and the divisions to 6. Select and delete the Merge Form node and change the display flag to the Out node. Now connect the Polybevel 2 to the Merge 3 node. OK, the hollow box is also now acting as a cutting surface, but we can see a weird shading on the polygons. This is because of the surface normals are not correctly calculated. To fix this issue, let's add a normal node and set the weighting method to by face area. And we have no more shading artifacts. Okay, now it looks like we have finished our model. Delete the Transform 3 node, we don't need it anymore. Add some color to the Box 1 node and reorganize the nodes a little. Change to Smooth Shaded to check. OK, change back to Smooth Wire Shaded. We can check our streams. First the blades, the spinner, the turbine, the casing, and all the streams. Maximize the network editor. Nice! You have successfully created your first network in Houdini. Thanks for watching this video. I'll see you soon in the next one.